Thanks everyone for coming. I'm Chris Oakes. I'll be moderating the panel today. To make sure you're in the right session, this is Feeding the World Efficiently, one krill replacement at a time. So we're here to talk about aquaculture and krill replacement programs. So the demand for seafood is accelerating as the global population grows. And many consumers choose fish over more carbon-intensive foods like beef and poultry. Synthetic biology can play a key role in combating food and nutrition gaps by supplying the ingredients necessary to increase farmed fish production. Krill are commonly used as a palatant and attractant for farmed fish and as human nutritional supplements. At the base of marine food chains, they're an important keystone species that could be saved by synthetic biology. So this session, we're going to delve into the world of animal nutrition and the immediate need for replacements of traditional wild-caught marine ingredients like fish meal, fish oil, and krill meal. We'll hear how synthesized nutrients can rapidly feed fish, other livestock, and even people while preserving our marine ecosystems, creating a diverse business opportunities, and will help grow the bioeconomy. So I will introduce the panelists, starting with David Say on your right. David's the CEO of NovoNutrients. He's leading the food and feed from CO2 bio company, NovoNutrients, that's clearly transforming carbon dioxide emissions into alternative protein ingredients. In 2017, he engaged with NovoNutrients, investing in it, pivoting it, and taking his current role as its CEO. David has been the sole manager of Aquacopia. That seed-stage fund and its 5-company portfolio had a thematic focus on aquaculture. The companies ranged from an aquafeed ingredient manufacturer to a distributor and marketer of sustainable seafood. The fund also led investments into OpenBlue, Innovasea, and Futuna, including a prior startup that David co-founded, and those 6 companies raised $250 million under his watch. After earning an economics AB from Princeton, David's career had started with internet pioneering that was a mix of general management, entrepreneurial, corporate development, and consultative sales of strategic technology and media services.
I promise I'll provide a shorter bio next time. I didn't realize it was going to be read out loud.
Yeah. In the middle, we have Stefanie Lobnig, co-founder and CTO of Aquanzo. And as co-founder and CTO, Stefanie is dedicated to advancing climate-smart innovations for the aquaculture and animal feed industry. As we've discussed, the increasing demand for alternative proteins due to the limited natural resources wait, this doesn't make sense. So Stefanie has developed a unique farming system that leverages underutilized feedstocks and genetic selection and is able to create a raw ingredient with superior taste and completeness compared to alternative proteins. Stefanie draws on her industry and startup experience in process engineering and scaling novel insect protein processes and is devoted to leading a team that contributes positively to the environment's well-being. So welcome, Stefanie. And we have CEO Larry Feinberg from KnipBio. Larry is passionate about developing and commercializing innovative, climate-friendly biotechnologies by incorporating strategy, creativity, and leadership. And at KnipBio, Larry led the efforts to develop, innovate, and deliver first-of-a-kind functional single-cell protein technology for use in aquaculture. So let's get started. Well, David and Larry, I'll pose the first question. All right. You've both been at this for a long time. What is it about the aquaculture industry that made you commit a significant chunk of your career and life cause to ocean sustainability?
I got into aquaculture in 2004 as an investor, and really, even at that point, it was the fastest growing major part of the world food system, sort of under the radar. And technologically, it was still very much in its infancy compared to terrestrial animal production, which has this long history of accelerating industrialization. And so there's a lot of innovation that could be accomplished in aquaculture, and it seemed like a good place for venture. I think I was definitely before my time, but I think we are now at a point where a lot of the platform technologies have matured, and it's a better environment for more rapid growth for aquaculture-related or early-stage companies.
Mm-hmm. And Larry?
So yeah, David was actually one of the first 10 people I met in this sector. So, what I found is that there's a lot of very passionate, caring people. But for me specifically, I've been a pescatarian since 1998, which turns out to be a pretty long time now, all of a sudden. And, for a lot of good reasons. Like, fish are awesome, right? We have so many different types of fish that we can choose from, unlike poultry where it's chicken or turkey or pig, there's one species, or cow, one species, right? And so to protect this diversity, but also, why was I not eating free-range organic turkey on Thanksgiving, but eating sort of more nefarious types of other marine proteins and instead? Was a big part of getting started here. And yeah, you are what you eat and what they eat too is kind of what keeps me going on.
Well, and I think it's also important to note that a lot of alternative protein companies look at aquaculture because of the price point. Wild-caught, ground-up fish meal costs a lot. Right, between $1,500 and $2,000 per ton, right? So that's always, I know we want to do ocean sustainability, but it's also an economic story. And fish can eat other fish. It's really hard for them to digest soy and other proteins. And so it's hard to come up with other alternatives. And so that's why a lot of the synthetic biology community and insect producers are trying to come up with these solutions. So there's an economic story behind this as well. And we've seen that price point go up about 5-fold since the early 90s. And so what is it, David? You always said about
the current FAQ fish meal price?
Yeah, I know you.
FOB
I know you know
Peru.
this.
I haven't checked in a couple of months, but it's probably like 1,700. It's pretty high right now. It might be 1,600, and that's fair average quality. So the range you gave is certainly accurate when you consider all the different fish meals. And there are different species of fish that go into different kinds of fish meal.
Exactly, and most of the supply is coming from Peru. We're also now fishing down the Southern Ocean for krill, which is why we're talking about both fish meal replacement and krill meal replacement. And as oceans become more acidic, krill can't reproduce, the temperature goes up, things are shifting. So for a sustainable and food secure world where we're eating fish, we need to have these alternatives, not to mention the whales and the other fishes that like to eat these things. So it's pretty important. Stefanie, you started with bugs in your career, and now you're working on sea monkeys, which is super cool. How are Artemia, or sea monkeys, related to krill? Why are you farming them? And what have you achieved so far at Aquanzo?
Thank you. Yeah, like you said, I started with bugs. When I first started with it, I was like, what the heck am I doing here? Like, put my hand in that box of larvae, and I was like, super interesting topic, but was definitely, like, it took me a week until I got used to it. Today we're farming sea monkeys, or Artemia, which smell much better, but are also much nicer to look at. How they're related to krill, they are both marine crustaceans. I would say that's about it. But they're nutritionally very, very good, and an addition or an alternative for marine proteins that we are currently taking out of the ocean and overfishing. So we started a company, my co-founder and myself, 2 years ago because we realized we can't farm krill. It's super hard. No one has actually proven it so far. But similar alternative is Artemia, and Artemia is super well known in the industry. There's more than 5,000 articles and papers about it out there, and it is also sustainable to produce. It is very well known, and regulatory wise, it's also used already. So therefore, no barriers, as I've seen in the insect industry.
And then part of your special sauce is the feedstock that goes into the Artemia production, and that's where I think we connect this to the synthetic biology world. Are you able to characterize a bit about the feedstock that you're working with?
So where we are today is we have developed a process that is taking in agricultural byproducts of feedstock, different feedstock, waste feedstock sources, fed to Artemia and producing a marine protein out of it. We're using IoT sensors and machine learning platform to connect the feedstock, the operation, and then the end out product of it. And so we're currently working with waste sources like from the dairy industry or from distilleries and have proven that it actually works really well to grow the Artemia. It changes nutritionally the composition a bit, but that is something that we're using as our advantage because we kind of can adjust it based on the accumulation that we want out of the feedstock.
Amazing. And so Larry and David, you're both working with single cell proteins, right? And Larry, I don't know if people know this, but if you look at KnipBio, it's actually pink spelled backwards, the Knip part. And so that's how KnipBio kind of got started. Can you characterize what's pink got to do with it? Why, and how does that relate to krill?
Well, we hired a very top tier marketing firm to come up with that. Yeah, so the organism in nature, it's a leaf symbiont. It grows on the surface of leaves. So literally, if you've ever eaten anything green, you've already eaten this organism. And it's pink, naturally, because of the carotenoids that it produces. Living on the surface of leaves, it's being bathed in sunlight. So it's kind of a natural sunscreen. But that's really helpful for immunonutritional properties that translate to those who consume it.
Got it. And so when we buy farm salmon from the store, little do a lot of consumers know that the salmon is not dyed with like a dropper of dye, but rather the feed is fortified with carotenoids.
Correct.
And carotenoids are antioxidants. There's different kinds, and so getting carotenoids into the fish feed is really important. Otherwise, you'd be eating gray salmon, right? And so there are different ways to do it. Synthetic biology is the way you've approached it for KnipBio. I wonder, David, from a NovoNutrient standpoint, how are you working with your single cell protein chassis and leveraging tools and technologies of the synthetic biology stack?
Yeah, so we're a really strong believer that the power of biology is to accomplish complexity in a single step, and so that makes it much better for certain applications than traditional chemistry. And so when you're producing a cell that has been, where the species and the fermentation characteristics have been chosen so that it has a high value set of amino acids in it, so that it can substitute for things like anchovy meal, you may want to add some additional value there, some molecules that wouldn't ordinarily exist in that organism. And so that's one approach. So, Larry started with an organism that already makes some carotenoids. The reason why we started with an organism that doesn't is twofold. Probably most importantly is because for us, the most important thing is feedstock also. And we also believe that wastes make the best feedstocks. And in our situation, we saw an opportunity to do biomanufacturing based on carbon capture utilization. And so we use small molecule gases rather than plant matter for our fermentations, notably carbon emissions. And so our synthetic biology program serves a number of purposes in terms of improving strains and creating new strains. But one of the things we do is making astaxanthin. That's sort of our proof of concept for this platform, which we think will be quite useful for a wide variety of food and feed additives.
Thanks, David. So 3 different types of feedstocks going into your process. David, it's food and feed from CO2, right? And what are the other feedstocks?
Oh, for mine? Okay.
Yeah.
Oxygen, hydrogen, ammonia or some other source of nitrogen, and then a few other inorganic compounds. And it's a fermentation that takes place in water. So the main engineering challenge in the fermentation side is the mass transfer of hydrogen. It's harder to get hydrogen into water than it is to get carbon dioxide, and that's one of the reasons why we drink liquid instead of some other gas in water.
Okay, so it's gas fermentation, but it is happening in a liquid.
That's right.
Liquid system, and you're using those gases as the feedstock. I'm going to go to Larry and then Stefanie. Larry, can you characterize the feedstocks that you're using, and a bit more about the chassis that you're working with?
So we also use a C1 feedstock, but this one is liquid methanol. It's one of the most scalable feedstocks. It's kind of a Swiss Army knife molecule that you can make it from a bunch of different ways: natural gas, biogas, E-methanol, which is hydrogen plus CO2, and syngas. So it's a really versatile molecule as a building block. But a non-food to food approach is very appealing, and it also has some really interesting antiseptic properties because certainly contamination, infection is a big concern at scale. So you have something that you can procure, that you don't have to necessarily worry about consistency, that it's highly consistent, 99.85%. 0.1 is water. So a very pure, very clean, very scalable with some of these extra properties as well, and potentially with an amazing carbon footprint. So this feedstock, like I said, was liquid, goes into a pretty standard aerobic fermenter. We actually use third-party toll manufacturing to produce our product. So it's nice not to have to build a plant to then figure out if anybody cares. And so that's been a big advantage to get the product out into the market and have some early adopters already. And then the organism that we have, you use the word chassis. It's a very good word. I like to use that also. But the idea is that it's almost like a Trojan horse in terms of the protein that delivers functionality beyond the carotenoids. There's other synthetic molecules like taurine, for example, that's not produced naturally by the organism, but it's really important for the aquaculture industry. And in fact, many juvenile trout, for example, won't grow without taurine, and taurine typically comes from fish meal. So as you're pulling out the fish meal to have a more optimal feed, you're losing other critical ingredients that, for example, like taurine, we can weave back into our protein. So that's hopefully answers a couple of the questions there.
Absolutely. And Stefanie, we've heard about the use of single cell proteins. Sometimes they're enhanced. I won't use the word GMM or anything like that. But I think in nature, bioaccumulation is a thing that happens, right? It's how krill turn orange, right? And then how salmon turn orange by eating krill. And so something that I've been wondering about is, in what ways could the synthetic biology community that's producing spent nutritious cells that might be engineered for something, could they leverage your Artemia product? Could your Artemia production leverage that spent feedstock in a way to upcycle the waste?
Yep, definitely. So what we have done so far is we have tested various feedstocks to see how the Artemia accumulate the nutrients or lipids available in liquids or also in the powdery solids that we have fed them. It's quite interesting to see which of them do get accumulated and which not, depending also on the process that we have. So when do you harvest them? How do you keep the operation? Which is why the combination of the feedstock, the operation, and then the end out product is very important to us. So as I said earlier, 2 of the few feedstocks that we have tested already are from completely different industries, but have shown very interesting results. So, as I said, dairy, but also distilleries and malt production. For us, the most important thing is that the product is small enough. So we're talking micro size. But because they accumulate like stuff that currently wouldn't be used or upcycled anymore because it's mechanically impossible or it's too expensive and therefore is going down the drain. These are the feedstocks that we are very interested in because, you could make money out of it. We can make money out of it. It's cheap for us to produce it, but we're getting, because of the bioaccumulation, we're getting these valuable sources out and producing a marine protein out of it with specific characteristics. We're also starting a genetic selection program at the moment where we're selecting specific Artemia for specific feedstocks as part of it. So basically rebreeding tailored Artemia for specific feedstocks 4 different industries. So that's going to come up where we just got awarded a grant, or which is starting next month, as basically a side stream, a very interesting one, where the GM community could also be like a very interesting next stage testing partner for that.
Yeah, I think about companies like DSM and Novozymes and everyone who's just got these, 200,000 liter CSTR tanks and all that spent media every 90 days. Like, how can we put that to use? Okay, well, we're about halfway done. I kind of want to pause from the panel and get a sense of the audience. Are there any questions from the audience? This is a good time to help steer the panel a little bit. I've got plenty more questions, but I'd love to understand what the audience is interested. David's agreed to give up his mic for a moment. So I'd love to get a few questions from the audience, and we can make this interesting and engaging.
Hi. I was just curious, if you look at price per ton, what do you anticipate would be your price per ton compared to krill and fish meal?
So right now, using third-party manufacturing, kind of at this relatively immature state, pricing is definitely higher than some of these commodity proteins for sure. So the question is, can you match up a value that matches that more expensive manufacturing? And in our case, we have, in that we are able to improve yield on the farm by improved survival pretty reliably and consistently over 50 animal trials to date. So that's the near-term strategy, is to get to a higher price point, and then as the COGS come down, to sort of open up larger volumes and access bigger markets.
On our end, we are starting to enter the market with a different product, a product that has already a market, a high-value market, with the egg production, so Artemia egg production, that are currently, the demand is increasing, the supply is decreasing, because Great Salt Lakes are drying out. You see that there are issues. So there's an existing high-value market that we're starting with in order to improve the technology and then get the price for the meal as a second phase down. So early revenues for then large-scale expansion into further next stage products.
So just to clarify, when you say selling the freeze-dried eggs, these are going into the basically ornamental aquarium market, where if you want to feed your baby fish, you grow those up, or could you clarify that a little bit?
So every baby fish or shrimp hatchery at the moment uses Artemia eggs, so the cysts, to feed their baby fish and shrimp, marine fish and shrimp. And so they are very well known already in the market. If we ask hatcheries, what would you do if there's no supply anymore? There's not really any answer at the moment. So we're like, okay, we do have a solution. We have a quick solution, which is why, like, we are at early stage. We're 2 years old as a company, but we have more than 2.5 tons of offtakes from these kind of supply users already, to say, okay, as soon as you have them, we're with these qualities, we want to buy. So it's a quick entrance to a market to then develop into like the higher, bigger market as the next phase.
Amazing. David, do you want to comment on Barbara's question?
So, well, first, maybe we talked about the fish meal price earlier. Does anyone know what krill meal is running these days? It's, I want to say, low 2000s.
Yeah.
So between 2,000 and 2,500, yeah. Just for context. So I don't know if people caught the BCG synonym talk about scaling around noon. Their position is that for cost-effective biomanufacturing, you need what they call something that's mega scale, which for them is 2 million liters or more in a facility. We tend to agree. Roughly, we think 1 million liters is a good scale if you're trying to compete with things like fish meal and krill meal. With our technology, which is a continuous fermentation process, we should be able to get 100,000 tons a year from 1 million liters. But the cost is primarily driven by the cost of hydrogen, right? So the CO2 is a waste stream. The oxygen is a byproduct of making hydrogen through electrolysis. But hydrogen is an energy commodity. But the good news is it's not as fungible as an electron. It's hard and expensive to transport. So there are opportunities to manufacture it away from other demand. So we're looking at $1 to $2 a kilo, depending on scale and the cost of energy, essentially, in a manufacturing location.
Okay. Any other questions from the audience? Yeah. Got 1, 2.
Hi, so I'm Chiara. I'm a PhD student at Rice University. I know that some fish are notoriously picky with their food. For example, tuna. I know it's really almost impossible to farm that. So how do fish do they like the food that you're doing? Like, how does that compare with the wild caught stuff?
Yeah, it's a great question, and tuna are definitely the holy grail in terms of farming in so many ways, and a lot of that's behavior. We sort of take it for granted what sophisticated animals they are, so that's a complex piece to it. One of our more fortuitous discoveries is fun with science when you're not really looking for something that happens is when we were doing these stress resistance tests, we saw that our animals that were fed our product, they'd never lost their appetite when they were under stressful conditions, and so I think it certainly speaks. I can't say that it's an attractant, but it certainly they're not dissuaded from eating our product under stressful conditions, whether they're being moved or a bacterial invasion or a virus. In all those conditions, we've seen maintained appetite, which if you sort of extrapolate into those conditions, it's particularly useful because if your only tool is a medicated feed, that's less antibiotic that's going in the water, more that's going into the animal. If they're not eating, they're pulling on their own reserves. So it becomes a real spiral. And so, I think this is one of the ways, one of the functions, when I think about functional single-cell protein, it is the nitrogen that's delivered, but what are some of the other benefits that we can deliver? And so it's a great question because it happens to really be applicable for what we're developing.
On our end, we have some preliminary results. Again, we're 2 years old, so not hundreds of these out there yet. But the first ones that we have gotten have shown that there's actually positive results compared to control standard starter feed diets, so that they actually like the taste more than what's out there. And we think because it's a transition between the live feed and then the dry feed, because it's a known taste for them. Therefore, they eat more without the stress in between, which was our hypothesis from the start, and it looks like it is proven so far with the results that we have.
We did palatability testing with the Japan Scientific Feeds Association. The model species for a lot of aquaculture is rainbow trout, which we also used in our safety trials in Montana. So the metrics for attraction and palatability in these trials were strike time, so how long does it take between the introduction of the feed in the water to the fish getting their mouths on feed, and then time to consume all feed, right? And on both of those, our figures were about half the control, which then the control included fish meal, and fish oil was the normal stuff. So we think that there's great prospects as a krill replacement if we think of krill primarily as a attractant and palatant.
And half is good, so faster to strike
Yeah.
and able to eat everything that's in the aquarium faster.
Usain Bolt.
Yeah, amazing.
Sorry, I missed most of your presentation, so I'm very sorry for that. But I was wondering, what's your impression from speaking, for example, the Norwegian salmon industry, which is really big, and they're quite conscious about the impact of the overfishing and so on, and they have 99% renewable energy and quite low energy costs. So for your hydrogen production there.
It'll be interesting to see what other folks say, but I think what the Norwegian salmon industry really likes to see is 10,000 tons a year of production already, right? And so we don't have that. We're not commercial yet. And so while we're working with that industry, they're not likely to make significant investments of resources, But we have a publicly announced relationship with Spreading, but it's pretty low key.
Similar on our end, we're too early, I would say, to tackle that market. I think it has a potential long term, but at this stage we're more focusing, first of all, as I said, on the eggs, so egg production, but then on starter feeds, on special fish that already have or that have issues, smaller volumes, before we then tackle the big markets.
Norway is clearly one of the most important, if not the most important, jurisdictions for aquaculture. It's also one of the most hostile in terms of what we do here, in terms of synthetic biology. So I think we have our work really cut out for us in this ecosystem and in this community to really make headway there. Not that we shouldn't, we should, and I think there are a lot of opportunities to do it. And the word GM, I think, means a lot of different things, a lot of different people, like deletions versus transgenic. So there's a lot of nuances there. But so far, in the last 11 years, 15 years, I think there's been a very strong reluctance by that community to adopt these types of strategies, which it's really important that we figure out how to work with that sector, because it's literally the most important one. So
I just did an event together with the UK Embassy in Stockholm where the Norwegians were present, and their main focus on SynBio is for the fishing industry. So it's
opportunities changing. Yeah, that's important to know.
And I'll just add that actually, when we're talking to aquaculture about just protein, we only talk about our natural strains, because we just think the market may not. Several markets are not ready for GMO feed ingredients yet. Although in Europe, the tides have been changing, and it was even now, almost 2 years ago now, that they took in their first batch of approving, I think it was 11, crop GMO ingredients for feed, which was a huge step and probably points in the right direction for the rest of us.
Hi, just following up on the regulatory question with respect to various parts of the world. I imagine that, Europe has always been remarkably resistant to anything that has a genetically engineered component in it, even if it's a cisgenic kind of thing. So one way to get around this, I would urge everybody in this room, is not to use the phrase GMO, because that immediately puts people's hackles up. Have you approached Singapore, Japan, or the US about these things?
Yeah. Well, first, thanks for introducing yourself earlier. It's nice to meet you.
I'm a former FDA CVM animal biotechnology person.
So I definitely had my own personal experiences interacting with your colleagues.
That was the Division of Animal Feed.
Correct. Correct. We won't put any ties or associations for sure. Protect the innocent here for sure. But yeah, it was for us a 5-year process from when we went down to DC and introduced ourselves to understanding what trials we need to run, running the trials, working with great consultants in order to write up the dossier, submit the dossier, and then have it reviewed, survive not one but 2 government shutdowns, and then to do it again for shrimp. And then to do it again for Canada. So it's a real challenge, and I definitely swing at windmills on this one. But if I could get one appeal to the global community, is to find some way to have some regulatory jurisdiction, reciprocity. Obviously, we need to be safe. These need to be tested. But every time in every country, it's just too much, right? So I don't know who wants to join me in fighting those windmills, but let's go, charge.
I think it's a testament to why SynBioBeta exists. We're trying to build the coalitions and the camaraderie that it's going to take to change the dynamic, right? We need the community, so it's precisely why we're here.
Amen.
Yeah, I was in Singapore last week, in part because they are real pioneers in terms of alternative protein for food and feed. They're very supportive of aquaculture. Through an accident of history, the only place where we have regulatory approval is in Japan. These are natural strains for all animal feed use. We have not attempted to get an approval for, I'm not supposed to say GMO, so SynBioBeta strains.
Enhanced
yet.
Fortified?
Not
Yeah,
sure.
Let's take a poll here.
Yeah.
I think that question is a bit out of our direction. We're not using any feedstocks yet, any GMOs feedstocks, but like are interested into looking into it, as I said, in the future to see potentially how we can use it as a vehicle to bring alternative proteins or marine proteins to various industries. But at this stage, no experience, I must say, and we kind of want to keep that Pandora's box closed for now. We'll see, scaling first, and then that's the next phase.
And are you saying that the GMO part would be what you feed to the Artemia?
Yes.
So then the Artemia themselves could still be natural?
Yes, exactly. That's the idea behind it, yes.
Amazing. Mark.
Hi, Mark Binger. I have, maybe this is a very naive question, but I was wondering if you are thinking at all about urban aquaculture as part of your roadmap. Just thinking about sort of there's a match at low scale and sort of early stage, and also a lot of production similarities basically as you go kind of into bigger and bigger organisms. So like I said, maybe it's a dumb question, but what do you think about that?
I don't know if I'm interpreting your question, which is not a dumb question, but if I'm interpreting correctly, we have a burgeoning and emerging sector called land-based, so recirculating aquaculture systems. They can be urban or not, sort of depending on the specific project. What turns out, capital intensity is probably those types of projects, number one problem. Number two would be off flavors with 97% water recirculation. You have the accumulation of compounds like geosmin and MIB. And actually, we've been able to demonstrate that our protein lowers those compounds. So making it easier to make the fish taste better, shortening and making the overall yield better. So that's another example of some of the functionality that can be woven in here.
Our process is indoor, is a recirculated system, adapted to like normal RAS recirculated aquaculture systems. So because Artemia are much more resistant, they have different properties. That's where basically our knowledge comes in, also based on what type of feedstock we are feeding them. Urban aquaculture, yes, could be possible. So we're designing multipliers, as we call them. So easy to build, no steel in the ground. So kind of greenhouse tunnels where you can plug and play them to industries. Like I said, big multinational players that have issues with waste sources that are currently going down the drain and where nutrients are actually lost. That could be plugged somewhere else as well. For us, it's at the moment focus. We have enough on our plate with, for now, dairy and the distilleries. But as I said, very happy to discuss anything further. And yes, it is possible.
I think the important thing for me in answering this question is that the way the value chain looks, like sitting in between ingredient companies, there are formulators, there are feed mills, right, that have recipes and they mix a variety of ingredients in to be nutritionally and economically optimal. And so if those intermediaries are selling to urban aquaculture farms, great. But I'm unlikely to have a direct relationship because it's important for there to be that sort of, in a certain sense, our customer is one step removed from that.
Yeah. Okay. Great. Thanks.
Hey guys, how's it going? Larry, David, good to see you guys. Stefanie, I don't know you. I'm Dan from ADM. We've been talking a lot about cold water species and some of the challenges that presents to getting to market. What about the warm water species? What needs to be true to go after your tilapia, shrimp?
Cobia.
Yeah, just curious. Yeah, thank you.
Good to see you too, Dan. With cold water, of course, we think about salmon, and salmon is the largest species, but it's still only 15% of all species raised, right? And shrimp is very close behind that. So it's a very helpful question to sort of make sure that we broaden the conversation. And when we think about the kingdom Animalia. I mean, how different is crustacean with its house on its back compared to a carnivore salmon with a vertebrate, right? I mean, they're very different animals. And so in our case, we've tested about a dozen different species in both cold water, warm water, along the spectrum, and see very similar results. Specifically, for example, with survival, and we know, shrimp, whether they're in flock systems or in other production systems, they lose a lot of shrimp along the way, and so we're actually able to quantify an improvement in survival from the earliest Napoli stages all the way through the larval and into juvenile stages. So it's very important. Stakes are higher in those types of systems because growth cycle. Well, stakes are high in different ways, I should say, because the growth cycles are so short and intense versus salmon. I mean, it's high because it's so long and you've invested so much into it. So in both cases, there's a vital role between nutrition and health and making sure that we get that right. Because, if the tendency right now is for lowest cost formulation, it's all about how cheap can we get these feeds. And it's a little bit more of you are what you eat, and if you're going for the lowest cost formulation, you're probably not getting the best ingredients all the time. And that leads to compromised immunity and more exposure to diseases and therefore lower yields on farms and just becomes this negative cycle. So I think it's very important, one, for us ingredient developers to think more broadly, not just only focus on a single species, but more across, even think about poultry and other animals as well. But the idea being that you are what you eat and that better nutrition will lead to better results on the farm.
So, warm water is important because biological processes happen faster at higher temperatures. And so good things can happen faster, like growth, but bad things can happen faster, like infections and other issues. I think, but from, to expand on what Larry said, every animal has an ideal amino acid profile that it would consume, which is very similar to the amino acid profile of its own body. And so I think less from a protein perspective between warm and cold as just, what are the amino acid pattern differences that are needed by a shrimp versus a salmon. It's probably worth, repeating again, like what is krill meal and why does it have value? So there's the protein part. There's the omega-3 lipids, so like EPA and DHA. There is the carotenoids, so the color. And then the mysterious other chemicals that are probably what makes it so attractive for fish to eat. And so, when we think about different markets that we can approach, your value proposition can have some or all of those components in more specific ways. Did you want to talk on this?
I think, like being the engineer from the insect industry here, talking aquaculture and specific species, I think I'll leave that to you guys.
No, wonderful. So we're about out of time. I appreciate the audience questions because it really helped address some of the ones that I had, which is, what does it take to get an ingredient adopted? You need to be producing at the right scale, 10,000 tons or more. It needs to go through all the regulatory approvals by species, by region, and then it has to be nutritious and palatable for the fish and characteristics like that. We're all using synthetic biology in some way to deliver new solutions to the aquaculture market and driving ocean sustainability. So that's an amazing feat for what the synthetic biology community is bringing to the table. So I'll ask one last question. Let's keep it real quick, but lightning round. And so could each of you share just one prediction or trend you think is going to significantly impact the aquaculture industry in the next 5 years?
I'm going to steal and go first and take the easy one, which is, of course, climate change, changing water temperatures. That's going to make people think a lot harder about the whole production system.
I think for us, running out of marine proteins, like aquaculture and other industries are growing, like we need good proteins, good ingredients, and so finding alternatives is essential.
I'm going to take two. one is just rising standards of living and the emergence of an ever larger global middle class. One of the first things that changes as people get more income and wealth is their diet. They want to eat more animals in most cases. And so that will put more pressure, particularly on the most efficient way of producing animal proteins, which is aquaculture. And then the other thing is sustainability will be increasingly important, and there'll be more and more value associated with what is the water, land, fertilizer, carbon footprint of different proteins. And the World Resources Institute uses this metric of what is the mass of carbon emissions equivalent to the mass of pure protein produced in a given thing, right? And of course, the worst offender is beef. That's about 2,400 tons per ton. The best is wheat, which is 70. And I think on this stage, we probably have some folks in the single digits or negative. So that's a good one to think about.
Amazing. Well, thank you all for joining. Thank you, panel. Appreciate all your awesome answers. All right.